Hello students, welcome to MGC Learning. I am Anjali. Today I am going to start with 12th standard mathematics topic definite integration part 2. So we already studied in the previous video about properties of definite integration. So today I am going to start with properties of definite integration. Last property, then we'll solve questions. So property number 8 is integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f of x is even function, otherwise equal to 0 if f of x is odd function. So let f of x is even function if f of minus x is equal to f of x. This is the definition of even function. If f of x is odd function if f of minus x is equal to minus of f of x. So this definition you have to remember. So we have to substitute when we are getting a question. You have to find the function is even function or odd function. If it is odd function, then directly you can apply 0. If it is odd function, you have to apply the first this one. F of x is even function, then you have to apply this. So integral minus a to a f of x dx is equal to integral minus a to 0 f of x dx plus integral 0 to a f of x dx. That is equation number 1. Hence, integral minus a to a f of x dx can be written as 2 into integral 0 to a f of x dx if f of x is even function. Because if it is even function, then this function will become 2 into this one. That is this definition says, and it is 0 if f of x is odd function. This is the definition of this. So you have to prove this. So consider I is equal to integral. The first part we are considering this. So integral minus a to 0 f of x dx. Put x is equal to minus t. Therefore dx is equal to minus dt. As x varies from minus a to 0, t varies from a to 0. We have already discussed in the previous video, if we are giving substitution in definite integration, you have to change the limit also. So here if the limit is with respect to x, we are taking this one. So x is equal to minus a to x equal to 0. That is the x limits, and if it is changing to variable t, then t varies from a to 0. So I is equal to integral a to 0 f of minus t into minus dt. So you can take this minus outside. So minus of integral a to 0 f of minus t dt. So in the next step you can write this as integral 0 to a f of minus t dt by using this property integral a to b f of x dx is equal to minus of integral b to a f of x dx. Next, in this step, you can change this variable from t to x. So, integral 0 to a f of minus x dx. That is by using this property integral a to b f of x dx is equal to integral a to b f of t dt. So, from equation number 1, we will get integral minus a to a f of x dx can be written as integral 0 to a f of minus x dx plus integral 0 to a f of x dx. So we can compare. See here in the right hand side, both the limits are same. So integral limits are same, only functions are different. So you can commonly take this integration. So integral 0 to a f of minus x plus f of x dx. So if f of x is odd function, then f of minus x is equal to minus f of x. Hence integral minus a to a f of x dx is equal to 0. If f of x is even function, then f of minus x is equal to f of x. Hence, integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. Next one question. So, integral 1 to 9 x plus 1 upon root x dx. Here we can split this numerator into two terms. So, integral 1 to 9 x upon root x plus 1 upon root x dx. So in the next step, you can cancel this root x with this x, that is root x into root x. So you can write in the numerator. So one of the root x will cancel. So integral 1 to 9 root x plus this 1 upon root x can be written as x raised to 1 minus 1 upon 2 dx. Now we will take integration. So x raised to 1 upon 2 is the term here. Integration of this term is x raised to 3 upon 3 upon 2 plus x raised to minus 1 upon 2 plus 1, that is x raised to 1 upon 2 upon 1 upon 2 from 1 to 9. you can take this constant outside of this term. So 2 upon 3 will come out. If we are taking the reciprocal and we are applying the upper and lower limit. So in the place of x, you have to give the upper limit. So 9 raised to 3 upon 2 minus 1 raised to 3 upon 2 plus. Similarly, in the second term, you can take 2 outside. So 2 into 9 raised to 1 upon 2 minus 1 raised to 1 upon 2. So 2 upon 3, you can write this 9 as 3 square. So 3 square whole raised to 3 upon 2 minus 1 plus 2 into, here again 3 square whole raised to 1 upon 2 minus 1 you can write. So 2 you can cancel. So this will become 2 upon 3. 3 cube is 27 minus 1 plus 2 into, here 3 raised to 1, that is 3 minus 1 is 2. So 2 upon 3, 27 minus 1 is 26 plus 2 to 4. So 52 plus 12 upon 3, that is 64 upon 3 is the answer for this question. Next question is integral 2 to 3, 1 upon x square plus 5x plus 6 dx. Here the denominator is in the format of x square plus bx plus c. And then the coefficient of a is x square is 1 here. So let I is equal to integral 2 to 3, 1 upon x square plus 5x plus 6 dx. That's equal to integral 2 to 3, 1 upon x plus 3 into x plus 2 dx. So we are factorizing this x square plus 5x plus 6 as x plus 3 into x plus 2. So now by partial fraction method you can find the values of this one. So 1 upon x plus 3 into x plus 2 can be written as a upon x plus 3 plus b upon x plus 2. So 1 is equal to a into x plus 2 plus b into x plus 3. Now we can put x is equal to minus 2. So we will get minus 2 plus 3 is 1. So 1b is equal to 1, therefore b equal to 1. Put x equal to minus 3. So minus a is equal to 1, therefore a equal to minus 1. So we can substitute both these values in these places. So 1 upon x plus 3 into x plus 2 can be written as 1 up, minus 1 upon x plus 3 plus 1 upon x plus 2. Therefore, this I will become integral 2 to 3 minus 1 upon x plus 3 plus 1 upon x plus 2 dx. That is minus 1. This is log mod x plus 3 plus log mod x plus 2 from 2 to 3. Minus 1 log. We are giving the upper limit. So 3 plus 3 is 6 plus minus into minus plus. So log 3 plus 2 equal to 5 minus. Now we can apply in the second term. So log we are giving the upper limit of the lower limit of this term. So minus 1 log mod 2 plus 3, that is 5, plus log 2 plus 2 is 4. You can give this way, or you can give for the first term you can give both upper and lower limit, then we can apply for the second term. Here I have given for the both term I have given upper limit first, then I have given lower limit here. Anyway you can do. So minus log mod 6 plus log mod 5, minus into minus plus is log mod 5, minus into plus is minus log mod 4. So this can be written as 2 log mod 5 is 2 times. So 2 log mod 5 minus, you can take this minus common. So log mod 6 plus log mod 4, that is log a into b is equal to log a plus log b, you can write. So we are applying that property of logarithm. So here 2 log mod 5 can be written as log mod 5 raised to 2 minus log, this is 6 4 24. So log mod 25 minus log mod 24, that can be written as log mod 25 upon 24 by using logarithm property, law of quotient. In this question, integral 0 to 1 x square minus 2 upon x square plus 1 dx, both the degrees are same. So we can adjust the numerator as denominator. So integral 0 to 1 x square minus 2 upon x square plus 1 dx can be written as integral 0 to 1 x square plus 1 minus 3 dx. So now we can split the numerator into two terms, integral 0 to 1 x square plus 1 upon x square plus 1 dx minus 3 into integral 0 to 1 upon x square plus 1 dx. That is integral 0 to 1 dx minus 3 into integral 0 to 1 upon 1 plus x square dx. Now after integration, x from 0 to 1 minus 3 into, this is tan inverse x. Integration of this one is integral 1 upon 1 plus x square is tan inverse x from 0 to 1, applying a higher lower and apply upper limits. So 1 minus 0 minus 3 into tan inverse 1 minus tan inverse 0, that's equal to 1 minus 3 into tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So we'll get 1 minus 3 pi by 4 is the answer for this question. Next question is integral 0 to pi by 4 sine 4x into sine 3x dx. So let I is equal to integral 0 to pi by 4 sine 4x into sine 3x dx. We have 2 sine A sine B is equal to cos A minus B minus cos of A plus B. So we can apply that formula. So here in this place only sine A into sine B dx is there. So 1 upon 2 you have to cross multiply. Otherwise, we can apply 2 in the numerator and denominator. That way also you can solve. So here I am applying this way. Sin A sin B is equal to 1 upon 2 into cos of A minus B minus cos of A plus B. So 1 upon 2 into integral 0 to pi by 4 cos 4x minus 3x minus cos 4x plus 3x dx. Now cos 4x minus 3x is cos x and cos 4x plus 3x is cos 7x. Now integrating this one, 1 upon 2 into integral of cos x is sin x minus integral of cos 7x is sin 7x upon 7 from 0 to pi by 4. That is 1 upon 2 sin pi by 4 minus 1 upon 7 sin 7 pi by 4 minus sin 0 minus sin 0. So 1 upon 2 into sin pi by 4 value is 1 upon root 2 minus 1 upon 7 into sin 7 pi by 4 is minus 1 upon root 2. That's equal to 1 upon 2 root 2 you can take it out. So 1 upon 2 root 2 into 1 minus into minus is plus 1 upon 7. Taking LCM you are getting 1 upon 2 root 2 into 8 upon 7. So cancelling you are getting 4 upon 7 root 2 is the answer for this question. Next question is integral 0 to pi by 2 sine raised to 4x dx. So let I is equal to 0 to pi by 2 sine raised to 4x dx. 0 to pi by integral 0 to pi by 2. This can be written as sine square x whole square dx. We have this fundamental identity. It's not fundamental identity. We have this formula sine square x is equal to 1 minus cos 2x upon 2. If you are applying fundamental identity, again you have to apply this formula only for cos square x. So don't do that way. Only just apply this formula. We have this formula sin square x is equal to 1 minus cos 2x upon 2. If it is sin square x or cos square x, we have to do this way. 1 upon 4, this is 1 upon 2 whole square. So 1 upon 4 integral 0 to pi by 2, 1 minus 2 cos 2x plus cos square 2x dx. So 1 upon 4 integral 0 to pi by 2 1 minus 2 cos 2x, again cos square 2x can be written as 1 plus cos 4x upon 2 dx. Now integrating integral of 1 is x minus 2 cos 2x integral is sin 2x upon 2 plus 1 upon 2 into x plus 1 upon 2 into cos 4x integral is sin 4x upon 4. So 2 4s are 8 from 0 to pi by 2. So 1 upon 4 pi by 2 minus sin 2 pi by 2 plus 1 upon 2 pi by 2 plus 1 upon 8 into sin 4 pi by 2, and lower limit we have applied. So 1 upon 4 into pi by 2 minus sin 2 pi by 2, 2 cancel, so 7 pi. Here pi by 4 plus 1 upon 8 sin 2 pi. Sin 2 pi is 0, that is why the last term 0. Pi by 4 as it is, then sin pi is also 0, pi by 2 as it is. So 1 upon 4 pi by 2 plus pi by 4, that's equal to 1 upon 4, 2 pi plus pi upon 4, that is 3 pi upon 4. So multiplying 3 pi upon 16 is the answer for this question. Some exercise questions are given to you. Thank you.